In this tutorial, we are going to verify trig identities. This is very similar to simplifying the trig expressions that we've been doing. But in this case, instead, we are going to have an equation given to us, and it's our job to prove that one side of the equation equals the other side. So the first step is to choose a side to start with. And typically, we want to choose the more complex side. So I can see in this first example that the left side is a bit more complex than the right. So that is the side that we would like to start with. So we start with that side, and I typically rewrite that side so that it's clear to whoever is looking at my work where I'm starting. Step 2, use trig identities in algebra to rewrite that side. So we're going to work through this just like we've been doing with our simplifying steps. And if you get stuck, number 3 here reminds you that sometimes it's helpful to write things in terms of sine and cosine. The first thing that stands out to me about secant squared minus 1 is that that is a Pythagorean identity that is equal to tangent squared. So this is just one path. I'm not saying it's the only path to get to our right answer, but we're trying to figure out the work that's going to eventually get us to sine squared. So I know that tangent squared is equivalent to sine squared over cosine squared. So I'm going to replace tangent squared with that. And then secant squared is 1 over cosine squared. So here we're dividing two fractions, which we know is the same thing as taking our first fraction, sine squared over cosine squared, and multiply it by the reciprocal of the second fraction, the one that you're dividing by. So the reciprocal would be cosine squared of theta over 1. And when we multiply across, since cosine squared is a factor of both the numerator and denominator, those would simplify to 1. And we would get sine squared of theta over 1, or just sine squared, which is what we were looking for. Remember, your work is very important, so it's, you need to make sure that it's organized and that I can read it from left to right or top to bottom. However it is, just make sure that I can read it. Let's look at the second one. Verify that 2 times the tangent of x times the secant of x equals 1 over 1 minus sine of x minus 1 over 1 plus sine of x. I would argue that the right side is more complex because you're trying to subtract two fractions that have different denominators. So let's go ahead and start with this side. So again, I rewrite it, 1 over 1 minus the sine of x minus 1 over 1 plus the sine of x. The denominator, the common denominator between the two, I'm going to go ahead and write over here. It would be the quantity 1 minus sine of x times the quantity 1 plus sine of x. So in order to get this fraction over here to have that denominator, it already has a factor of 1 minus sine of x. So I need a factor of 1 plus sine of x in the denominator, which means I also need to multiply by that in the numerator, so that I'm technically multiplying by 1 and not changing the value of the expression. 1 times 1 plus sine of x is 1 plus sine of x. I have a minus sign here, so I'm going to put the minus sign over here. And then over here, I have 1 plus sine of x, so I'm missing the 1 minus sine of x factor in the denominator. So I'm going to multiply by that in the denominator and the numerator. So 1 times 1 minus sine of x is 1 minus sine of x. Now, if you write it like this, technically you're not correct because you're subtracting the entire numerator. It needs to be in parentheses. So technically, our numerator right now is 1 plus the sine of x. And if we distribute the negative, it's going to be minus 1. And then minus negative sine of x, or plus sine of x, all over our denominator, 1 minus sine of x times 1 plus sine of x. So to simplify the top, positive 1 and negative 1 is 0. And sine of x plus sine of x is 2 sine of x. That's a good sign to get a 2 in there because I know we're looking for 2 times the tangent of times the tangent of x times the secant of x. 1 minus sine of x times 1 plus sine of x, we're going to go ahead and multiply those binomials together. So 1 times 1 is 1. 1 times positive sine of x and 1 times negative sine of x here, those two things are going to cancel. And then negative sine of x times sine of x is minus sine squared of x. And what I notice is 1 minus sine squared is actually cosine squared. So we would have 2 sine of x divided by cosine squared of x. And keep in mind, cosine squared is just cosine times cosine. So I could really write this as cosine of x times cosine of x. And hopefully we can see how this is related back to tangent and secant, right? I could split it up even more. I could think of it as 2 times, and I could kind of group the sine and cosine together. So sine of x over the cosine of x times, I still have a cosine of x in the denominator, so 1 over cosine of x. And that does give us 2 times sine over cosine is tangent, so that's the tangent of x. And then 1 over cosine is secant, so secant of x. Let's do one more example. Verify that cosine of theta times the quantity secant theta minus cosine theta equals sine squared. So I would say that the left side is more complex. So we would have the cosine of theta times the quantity secant theta minus cosine theta. If we were to distribute cosine, cosine and secant are reciprocals. So when I do cosine times secant, which as a reminder is 1 over cosine, that's 1. Cosine times negative cosine is minus cosine squared of theta. And this is a Pythagorean identity. 1 minus cosine squared is sine squared of theta. And so we would be done.